I mentioned this executor or executor is something of an event loop. Let's say that the bot has some additional state associated with it. Let's say that the bot can be kind of impatient, and based off of that impatience, the bot might respond differently to one of these answers. For example, if we look at our conversational flow, maybe if you just say hello, but you don't ask how it's doing, maybe in state E, when it tells you the weather, it tells you the weather. But if something happened up here, it also says something a little bit snide, maybe a little bit passive aggressive, saying the weather's fine, not that you would care how, I think about this, and you want to track some state through this machine. If we think about that, it starts to get really, really tricky for us to model in this representation. Because what we're talking about is, we're talking about some state machine where we have state A that goes to state B or state C, or state B and C both go to, or both have the option of going to state D or E, which then go to state F, and this loops around to the top. And we're talking about implementing the execution of this via an executor that looks like this. I call this executor an event loop, in part because this executor defines for us how we do the state transitions, how we go from one state to the next, how those predicates look like, and it also defines for us what arguments those predicates take. Note that this is a predicate on the response. This is not a predicate that is determined by any of the previous responses, which means in response D or E, if we wanted to say, today's Tuesday, it's the best day of your life, but I'm feeling a little bit down, just to make you feel bad for not asking the bot how it's doing today, well, you'd have to update this predicate to include some of that past information. So we wouldn't be able to make use of the executor that we had written before. If we wanted to add in that behavior, we'd have to do something like have this maybe track what the previous responses are. So he might have a previous responses. Is a list here, and then every time we get a response, we might have to store that for the previous responses. And then in this predicate, we might have to send in the previous responses. And then up here in each one of these transitions, we'd have to have one more variable that is sent in that represents the previous responses. And you can see that's quite a bit of work for us to accommodate what appears to be a fairly simple change. The other way we could do this is we could duplicate the states that we have. This is a very common way that people try and solve these problems. What you could do is you could say, okay, based on the B or C criteria, maybe there's a D state and a D prime state. Maybe there's an E state and an E prime state. And the D state is the regular non-passive aggressive version of the today is Tuesday. And the E state is the D prime state is the passive aggressive version. But when you think about that, you could think that that only is going to work if we have that distinction of passive aggressive or not, just that one binary distinction. What if there's more data that needs to be carried through? For example, what if the bot wants to respond differently based off of how quickly you replied to it? Now, of course, in this simple execution version, we're assuming that all the responses are predetermined, but you can think this is actually going to be part of a back and forth, and there's actually going to be some maybe network logic. Instead of popping this off a deck, there's some network logic that goes and retrieves those. So we could actually say, if you were slow to answer the question, maybe the bot says, hold on a second, are you maybe not aware of what I am able to do? Or maybe even the bot says, look, let's start the conversation over. It's been so long since we last spoke. I think we need to start with another hello. Whatever the case may be, the information that we need to have move through this state machine could be a very high fidelity. There could be a lot of information, and we wouldn't just be able to duplicate the number of states because there may not be a finite number of modalities that arise there. In that case, we pretty much have no choice but to amend the event loop to thread that information through. But here's the thing. We now have talked about two different pieces of information that need to be threaded through to the later states, both responses to the previous states and also information about those responses. And this starts to get very clumsy because every time we find one more piece of information that a later state might need in order to make its decision of what to do next, we have to update this event loop, and we have to update all of our transitions to be aware of that. Think about this. When I first wrote the executor or the executor, when I first wrote this block of code, you might have thought, oh, you write that once and then you're done. And then every new bot I implement is just writing the different transitions for that bot and the different individual things that the bot will say. However, that's not the case. Because if one bot over here needs to track a little bit more information as part of the conversation, I have to change the executor, which is being used by all of the bots. That's not possible. Well, it turns out that I may end up making this executor either way too general, including information that not all the bots need to track through, control flow or data flow that not all the bots care about, or way too specific. I end up writing all three of these pieces, the nodes, the transitions, and the executor, every single time I want to write a bot. And that's not ideal. That's not the best way for us to do this. And so what we can see here is we have some issues with modalities associated with this. Now, the last thing I want to talk about is the composability of this. Let's say we have multiple bots, and those bots all have some common units associated with them. So it's not just our weather and date and time bot that has some of this information. Maybe there's multiple bots, and each one of them need to share something. Well, is that possible to do? Could we have some extracted nodes and transitions? Well, it turns out this is not altogether that difficult. Let's say we have bot 1, and these are the nodes for bot 1. Well, we could always unpack the common nodes into this, and for bot 1, we have the transitions, and I guess we could unpack the common transitions here, and then we add the bot 1 specific nodes. Now, of course, we'll have to name these a little bit better. You know, A, B, C, D, E, F maybe is not the best naming, but here maybe we have bot 1, A, and so forth and so on. And then for the transitions, we just have to figure out a way to link the bot 1 portion of this graph into the common one. So maybe this one has, as part of its transition, that A node falls into that part of the conversation, and then so forth and so on. So we can actually compose these fairly well. We can extract common parts of this graph, the subgraphs or the subflow charts, move them off into their own representation, and then bring them back and just kind of link everything up. But I don't want to go too much further in describing the modelings where we have this explicit nodes and transitions modeling, because I want to show you a completely different way to model this problem. Here's the deal. When we think of the conversation has multiple parts associated with it. The thing that the bot says first, your response. The thing that the bot says second, your response, and so forth and so on. It's a computation that can be broken down into multiple parts, which is exactly what a generator is. Let's think what it would look like if we were to write our bot conversation as just a function. Well, here it says hello. Then it says, what do you want? Then it says, well, I guess it needs to respond to that question, but let's just assume one thing. Today is the best day of your life. And then it says goodbye. Now, this isn't a particularly good representation of the bot because you can see when we call this function, the bot races through everything it wants to say. It doesn't even wait for you to answer it. Well, I guess we could pass in the responses like this, and we could do something like responses, or the response is equal to the responses.pop left. And irrespective of what you say next, it'll always respond, what do you want? But then the next time it'll say, oh, if the response was, hey, is it? It'll answer one thing. Otherwise, if the response was, maybe here, if the response was, what was the other question? What is the weather? Then it'll respond something else. And here you can see the weather is fine outside. You should go have a picnic. And then it says goodbye. Well, this seems to work fairly well, but it requires that we have all the responses available at the very beginning of our conversation, which is unlikely to be the case. Here, we would need to know the other side of the conversation before we called. Here, let's put in our deck before we called this function, which is definitely not the case. But here, just to show you that this works, we'll respond hello, then we'll say, what day is it? And of course, we need to pop this off before everything it responds. And let's see, and then the last thing that we're going to do is say goodbye. So there we go. This should be from the collections module alone. And we should probably mark what the bot says versus what we say. So there we go, and here we go. And let's mark what we say in terms of the response that we had. So here, I think this is good. And we'll put this every time we pull a response out. So we should see a full conversation. And of course, this should be responses. That's our deck. Here, we need to add in some parentheses. Oh, we have our full conversation. What do you want? What day is it? And so forth and so on. But unlikely we have all of these up front. But if we look at this, this is a kind of a function with parts associated with it, each step of the conversation. So why can't we take this modeling and make use of what we had just spoken about, generator coroutines? What we'll do is we'll make this a generator. And each step of the conversation, we'll just delineate that with this yield. So here, when we have this conversation, we can step through this conversation piece by piece. We can do next. And I think we just need to do 3 nexts to see the full conversation. Okay, there we go. And if the conversation ends early, well, we don't have to run every step of the conversation. Hello, hello, what do you want? And we're done. But what we really want to be able to do is send data back into the conversation, not have the entirety of the conversation known ahead of time. And so what we could do is make use of that send method in order to have a live conversation. Here, what we'll do is we'll have the bot say hello, and the response will be, you send back into this thing. We'll then have the bot reply to that, and the response will be whatever you send back into this thing. We'll have the bot reply to that, and then the response will be whatever you send back into this thing. So now we can do something like this. Now we'll do a first next. We have to do this a little bit. We have to do this a little bit differently. We have to put a dummy in. Actually, we'll have to do a first next to get past this. And then we can say, send into this thing the hello. Send into this thing the what day is it. Send into this thing the goodbye. And let's remove the need for this argument up front. And you can see we have, and we'll do a final next here. One final next. And then you can see we get the stop iteration, but we get the entirety of the conversation. Now we're a little bit off by 1 here as a consequence of evolving this code. Well, here, maybe we don't want to have the printing happening inside the function, so maybe we'll have the bot yield out its response, and maybe we'll make use of that pumping in order to remove some of these dummy necks and to fix some of this off by 1. So let's do the following. We'll model a conversation. The conversation starts with a dummy yield, and it gets the response from the user. Irrespective of what that response is, well, here, and actually, I guess since the bot starts first, maybe in this version of this, you say hello first and the bot responds with hello. But here, we yield hello always. And then you get a response from that. If your response happens to be maybe how are you, then the bot responds, I'm fine. And then maybe it also asks, what do you want? If the response is directly what you want, here you can see it says, what do you want? All by itself. Then in the next step, what we do is we say, okay, if the response, and here we don't have to do this with the assignment expression, we do this in multiple lines, but if the response was, what day is it? The bot replies with, today is the best day of your life. I don't know, is that a friendly thing to say, or is that kind of sinister? Whatever the case may be, we don't always know the intentions of the bots. The bots are very hard to read. Otherwise, if the response is, what is the weather? Bot responds, the weather is fine outside. And then bot replies, goodbye. And it doesn't really care what you say. There's really nothing you can say at this point that it's going to respond differently to. We have the same kind of state machine, but let's run this forever. Now we might have a conversation that can loop forever. Let's see how this might work. And here we're going to put one dummy yield at the beginning so we can pre-pump this thing. Start a conversation. We're going to, each step along the way, send in our response. So here we should just do the first hello. Remember, we can't send an unknown value to a just started generator, so this will fail. And of course, we need one thing here. I'm actually going to do this. Actually, do this a little bit differently. Yield hello. We'll have the bot start this thing again. So we have a lot of choices for who starts the conversation. Of course, some of the details of whether we want to presume that one person or another starts a conversation, that can be adjusted. But fundamentally, we can't set an unknown value to a just started generator. So we'll use our pumping trick in order to pre-pump this thing. Of course, we need to grab what the coroutine instance looks like. We'll need to do a next here, and then we'll grab just that. We say hello, it says hello. Then we say, what day is it? And that's a response to what do you want. You can see we're off by a little bit here. So what we probably need to do to make this work is we probably need to actually have hello come first. So we say hello, and then it responds hello, and then we say, what day is it? So there's a little bit of this question of how do we set, this is a linear conversation, one person, another person, one person, another. How do we set that up? Next thing it's going to tell us is what day it is, and we'll say goodbye. And here we need to do one more next. Doesn't really matter what we say here. And just to make sure that we got this right, here we're actually supposed to respond. This is where it gets a little bit tricky with this model, and we've got to make sure that we got this right. So we said hello, it said hello. And so actually, we probably wanted to say, what do you want? We can think about that in a moment, but we said hello, it said hello. We asked, what day is it? It responded, what do you want? Not quite right. Then we said goodbye, and it said goodbye, and then it looped up to the beginning.